Welcome back to the GT350 Garage for part 6 of building a 480 plus horsepower 289 Ford for my 66 Shelby GT350. This video has taken me about 2 months longer to get out than I wanted it to because of sickness and then problems with the build, and stuff like that's just not something that you can really do anything about. But in this video, we're going to put the short block together. So we're going to install the crankshaft. We're going to set the thrust and then measure it. And then we're going to install the rods and pistons. In that process, I will show you how I align the rings and then or the ring end gaps, so where I put them on the pistons. And then we're going to check rod side clearance just so that we can verify that the oil can get out of the rod journals. Basic process. I'm going to walk you through it, and from there we'll be moving on to the next video. But along the way, I'm going to show you the primary issue that I had during this process, and it all starts with this thing. This is a tapered ring compressor, and while these are very cheap and very common and widely used, they are garbage. Okay. I don't know if you can see this, but they don't like to stay square. And when they move, if they twist at all, and they do twist, you'll get a little tiny piece of the ring compressor sticking out. And when that happens, it can get down in between the piston and the cylinder wall, lock everything up, and give you a whole bunch of grief. And that's kind of what happened in this video, which then, as I was trying to move it, it allowed the compression ring to pop a corner out, and I didn't see that. One ill-fated tap, and I heard tink on the cardboard that I keep underneath the engine when I'm building it, and that was the piece of ring. So I'll show you what happened in real time, and we'll go from there. Where does this belong? In the trash. What should we use instead? Tapered ring compressor. Now, I've had this one for a very long time. It was given to us by a friend of the family. He worked at an engine remanufacturing facility where they built engines for Ford. This was the standard installation tool for a 302 Ford with a standard bore. When Ford started boring blocks, they stopped using the standard bore and went to a 4030. So I think that's how he ended up with it, and then he gave it to us later. This is the one I'm going to use in the video. This is a 4030. It came from Proform. These are about $40 for the individual sizes. For like 60, they sell a version that's split. The split version has a clamp on it, and you can open it up to like 4090 and then take it down all the way to 4-inch. Why didn't I buy that one? Well, this was available sooner. That's the reason I bought a specific size as opposed to the one that was adjustable. And I don't regret my choice. I think in the future, if I need to do a 40 over engine, I will buy a 40. If I need a 60, I'll buy a 60, and so on and so forth. So with that, I do want to say thank you to the now more than 7,000 subscribers the channel has. And I also want to thank everybody that leaves likes, leaves comments. You guys are awesome. I appreciate you. And I genuinely, I do. If you have basic questions, go ahead and leave them in the comments. I'm happy to answer them. And I try to answer all of them. And then if you have a more in-depth question, shoot me an email. I'll let you know, if as long as it's, not going to take hours of my time to send you an answer. But if I can shoot you an answer by email, quite often that's faster and more efficient than sending an answer through the comments. So anyways, with that, let's put a short block together. Next step is we're going to pull all the main bolts, main caps, and we're going to get assembly lube in place, and we're going to install the crankshaft. All right. For main bearings, and rod bearings, I use Lubriplate 105. The reason for that is this stuff stays in place and it doesn't go anywhere. Tap it down to the bottom of the tube. Let me do this so that you can see it with the camera. Put a good daub of it in every bearing. Throw on a glove, because I'm going to be honest with you, you have no idea what's in the stuff. Last thing you really want to do is put it on your skin. Don't be afraid to liberally lube these up. Okay, now, in the middle, number 3 is your thrust bearing. And that bearing needs to be lubricated on both sides. So, again, just put some on your finger, on your glove, on the fingertip of your glove, and go ahead and paint that thing up. This is a case where you can't really use too much assembly lube when you're using this paste type assembly lube. And it's not going to hurt anything to use it. All right, it's time to put the rear main seal in, and we're going to use a more modern rear main seal. Ford did not put a pin in the block for the rope seals, but they did put it in the main cap. Now I have a little bit of assembly lube on the seal, and that's to provide some protection on startup so that the crankshaft doesn't damage the seal. And when you put the seal in, it needs to stick up about 5/16 of an inch so that you don't have the gap in the seal in the same exact spot as the gap in the main cap. Otherwise, what will happen is you'll end up with an oil leak at your rear main seal. They have to be offset or staggered just a little bit. Now, the pin in the main cap is right there, if you can see it. And if you look inside, there is still a pin in this main cap. So we're going to remove that because this had a rope seal in it. Okay. If we look now, we can see that the pin knocks off flush. It's still in there and it's not going to go anywhere. It'll never go anywhere, but it knocks off flush. And by getting that pin out of there, it makes it so that our seal won't be bound in the top. So we're going to put a little bit of lube in the actual channel, and that's just to make it so that the seal slides in the channel. Move that around in there with the... And then this cap is going to be like that. So we're going to put this in and we're going to slide it into place. So it's about where we want it. Again, we're going to put a little bit of assembly lube on the seal, and that's just to keep us from burning the seal. So now the seal's protected. Set the crankshaft. We're going to put our rear main cap on over our seals. We're going to use a dead blow hammer to tap this seal into place. Doesn't quite feel right, so I may not have the ends of the seal quite where they need to be. Got the height of the seal the same on both sides. It's where I want it. Add a little bit of lubrication to the crankshaft. We're going to put that bolt in finger tight. Now, smack that one into place. And this is just to make sure that the seal is where we want it, that everything is good.
Okay, everything's good. So we'll loosen the bolts back up because we don't actually want the main caps tight yet. Make sure your arrows are pointing forward on your caps so that you have the correct orientation. That's super important. And then get out your speed handle if you have one. Don't get ahead of yourself. That's what I'm doing. You need to put a little bit of assembly lube on the bolts. And I use ARP assembly lube even on the stock bolts. Do not use engine oil. Cannot stress this enough. It will hydraulically lock in the threads. Which is the last thing you want to do. You don't need a ton of this. But don't use engine oil. I've seen guys dunk these in a cup of oil and then throw them in. And the problem is the oil will hydraulically lock the bottom of the threads. And that affects the final torque in a very negative way. So get a little bit of assembly lube on every bolt. Start in the center and just run them down until they stop with the speed wrench. Sometimes they don't want to go. Okay. Now, this is the part that a lot of people freak out. Don't freak out. Get a wood block. Put it on the end of the crankshaft. Smack the crankshaft. Put it on the front of the crankshaft. Smack the crankshaft. Do that 2 times. And when you do it, turn the crankshaft 180 degrees. And then the final time you're going to do it, turn the crankshaft 180 degrees. Do it from the back. And what we're doing is we're setting the thrust. Now, our main bolt torque is 75. Okay. Get your feeler gauge out. How much thrust do we want? About 8 thousandths. 6 to 8 thousandths. 8's on the big side. And how much do we have? Well, let's see. 8 will not go in there. Let's try a 6. And a 6 is a really nice fit. 6 feels good. So I'm happy with 6. 6 is fine. Anything more than that, we'd be looking at the crankshaft. The other way we can test this is we can put a dial indicator on the crankshaft. I can set up a magnetic base, and we can test it with a dial indicator. All right, so there's your dial indicator. Let's zoom in on that. All right, so there's your dial indicator, and we are all the way forward. I've got a pry bar holding the crankshaft all the way forward. And now I'm going to move it back. And there you can see that it's 6 thousandths, just like the feeler gauge said. Well, let's see. There's 0. It relaxes. And 8.5. So 8.5 is still fine. I'm not worried about 8.5. And that's using an actual pry bar to move the crankshaft as opposed to a feeler gauge. All right, so we're going to put a feeler gauge in it using the same method of a pry bar, and an 8 fits in there nicely. We'll turn it. And an 8's a nice snug fit. So dial test indicator says 8.5. Feeler gauge says 8. 8 to 8.5 is absolutely acceptable. All right, before we get started putting the pistons in, I've already taken the time to go ahead and lube all the bearings, both sides, and I've lubed all the bolts with ARP assembly lube. And this way I'm ready to go and get things on their way into the engine. Now, something that I use, and this is for assembly purposes, is when we're putting these pistons in, we're going to be using WD-40. I keep it in a squirt bottle. I label it. We're going to spray that in the cylinders. We're going to spray it on the piston skirts, and we're going to spray it on the rings. I buy it in the gallon, and that's just the way I do it. Now, the assembly lube on all of the bearings, again, is Lubriplate 105. So at this point, let's get started. We're going to put the pistons in the block now. right, well, this isn't a view I wanted to show anybody, but this ring decided to catch, and one light tap too many, and it snapped the corner off the ring. So I'll be ordering rings, filing rings, and starting over. Sometimes you have to go backwards to go forwards. You can see that the rings are all removed from the pistons. These have got WD-40 on them from install, and I have two set aside over here, and I'm going to show you why. All right, this is the compression ring off a number one cylinder, and as you can see, it has been filed and the gap was set. It was installed in the cylinder and everything went just fine. Then we moved to cylinder number two and all hell broke loose. There's the ring. We'll line it up and you can see right there that it is missing this lovely little chunk. Well, how did that happen? Pretty easy. The ring slipped out of the ring compressor just like this. And when it popped out of the ring compressor, one ill-fated tap and it popped that corner right off of that ring. I didn't catch it that it had popped out, and unfortunately this was the consequence. So I had to come up with a game plan. I could either order new rings or order a replacement set of new rings and just file one ring and set the other rings aside, or I could just make a decision to go another way. And that's what I did, but I'm going to explain how this happened first. Herein lies the problem. This is your typical ring compressor. Now, you wrap this around the piston, you unlock it, wrap it around the piston, it expands, and then you crank it down until it tightens up on the rings. What a lot of people don't realize is when we're dealing with pistons, the piston at the skirt is bigger than at the top ringland. The top ringland is smaller because if we're looking at the top ringland is going to expand more when it gets hot. The second, third, and the skirt, they don't expand the way the top ringland does. So because the top ringland expands, it causes an issue where the ring compressor can move on the piston when it's on the top ring. That's how this problem happened. Okay, so let's talk about what we're going to put in place of the rings that I just removed from the pistons. These are Molle performance rings. This particular set, I'm going to hold this up so that you guys can see it. This particular set is a 16/16 3/16 file fit low tension ring set. Now, normally I don't buy file fit sets, as I said in my video where I was filing the rings, but due to delivery time availability, this was the best option for time frame. I did not want to wait until April to get a set of rings. Now, Molle includes a nice little instruction set, and in the instruction set, they do something a little bit better than what we saw from Summit and Hastings. And in here, they give us, for a 4-inch bore, they give us an example size. Okay. And that's actually really cool. So as we go through here, high performance street, naturally aspirated, they're saying 18, 20, and minimum 15 on the oil rings. And then circle track, drag racing, NA, 20, 24, and 15.
Nitrous, we're not playing with nitrous. Turbo supercharger, we're not putting boost to this thing. And then turbo supercharger race, bigger numbers still, from 24 jumps up to 28. And then we have diesel turbocharged, 24 and 22. So what's interesting about that is on a diesel, which is a very high compression engine typically, we're running a smaller gap on the second ring than we are on the top ring. Let that sink in. Smaller on the second than on the top. Okay? That's because of heat. So we know we're going to create heat. We don't want the heat to cause the ring to butt on the top ring, but we want the sealing on the second ring. And we're running on a 4-inch bore. We're running less clearance than we would on a turbo supercharged engine by 2000s. So the only reason that this is really an important observation, diesel runs at lower RPM but higher cylinder pressure. So we have the heat on the top ring, we have less heat on the second ring. It's just a different way of doing this. Now, in the past, I have done ring sets where I've gone with a smaller gap on the second than on the top, and I've never had a problem doing that, despite many, many people telling me how wrong that is and that it won't work. Thank you for telling me it won't work, but it worked just fine. So, as far as where are we at with this? Well, what we're going to do is we're going to go with the same 20 and 22 that we were at before, because this is a 4030 bore that is just ever so slightly bigger, 2000s bigger than the street numbering here, and that's going to give us ideal numbers. So I'm going to get these things gapped and then get them on the pistons, and then we'll get back to putting the pistons into the engine. Okay, so let's talk about ring gaps really quick. Most ring manufacturers are going to give you the same exact arrangement as this, and that is, here's the front of the engine, so that's the back of the engine. This is going to be the lifter valley or intake manifold side of the cylinder head, or the block. So this is your intake side, and this is your exhaust side. Okay. Now on the piston itself, you're going to have an intake valve relief on this side on a Ford and an exhaust valve relief on this side. Okay. So if we're putting our rings on and we want to do anything other than what we have going on here, I'm going to tell you how I set up my ring gaps. I'll move the top ring gap here. I'll move my second ring gap here. Okay, so we're basically moving over and we're moving over, right? And then what I'll do is my expander, which they generally want the expander at the top of the cylinder, I'll put the expander here. And then I'll put my second oil here. And I'll actually put my top oil here. And you might say, well, why did you line up all your ring gaps? It works, okay? It just works. You can put them anywhere you want, but this works. It doesn't matter if you have the top oil and the top compression ring lined up. It's not going to cause a blow-by issue because it's a solid second compression ring through here. So you really don't have to worry about oil slipping through. You're not going to get oil contamination in your combustion chamber or anything like that. So there's really not a wrong way to install piston rings, as long as the top and the second compression rings are 180 degrees off of each other. if you want to go closer than 180 degrees, make sure they're 120 degrees apart minimum. Okay, your top and your second oil rings should be at least 120 degrees apart, and they should be on the opposite side of the expander. Now, some guys might disagree with putting the gap on the expander over here. It literally doesn't matter. It's hiding in the oil grooves. The piston doesn't care where the expander gap is. The oil rings don't care where the expander gap is. All that matters is that the top and second oil control rings are on the opposite side of the piston from the expander. That is literally all that matters in the oil control ring setup. And then just make sure that your top and your second are off 180 degrees or close to. Now, why would I put the top next to the intake? This is going to be one of the cooler areas in the combustion chamber. We're going to have our spark plug down here. So our spark is going to happen in here, right? So our cylinder pressure is going to be here, and it's going to expand out. I don't want to put my top ring that close to the source of combustion. I also don't like putting my top ring on the exhaust side of the piston, just because that's a hotter side of the piston. So that's just me, and that's how I do it. When in doubt, follow the ring manufacturer's guidelines. It works. It's not going to fail you. All right, I've changed the camera angle from the time lapse because I want to show you the final piston in the install process. So we're using a tapered ring compressor now. Makes the job go real easy. Other things we're doing. This is WD-40. Spray the cylinder liberally. Don't be afraid to use some WD-40. Same thing for your piston. You want to get the skirt, you want to get the rings, okay? The engine needs lubrication. Now, I covered this previously, but I want to cover it one more time. This is a Molly ring set, and I actually like the way Molly wants the ring staggered. Second ring is on the lower side of the piston. Top ring is, the gap is at the 12 o'clock position. So 12 o'clock, 6 o'clock, the ring expander's at 12 o'clock, and then the top oil ring is at about 4 o'clock, and the bottom's at about 8 o'clock. All right, tapered ring expander works really slick. You're just going to slide it on, get your rings in. And if everything goes real smooth like, this should just drop in without having to tap it in with the handle of a hammer. And this one didn't go super smooth, but those are real light taps. No force required. Now, we've got all this extra WD-40 on the deck. We're going to sop that up. Get it off the tops of the pistons, because we don't need a ton of it there. And just clean that up real quick. Now, I'm going to hit pause, roll the engine. Well, actually, you know what? I'm just going to roll the engine live while we do this. Now, our connecting rod moved down, so I'm going to guide the connecting rod onto the rod journal. And I do this normally with the crank
at the lowest position. In this particular cylinder, I didn't. It's fine. It doesn't matter. You don't have rod bolts on these Eagle rods. If you have rod bolts, I would suggest, if you're new to engine building, they sell little guides that you can put over your rod bolts to protect the crankshaft and prevent scratching the crank journal. Not a bad plan. Now, rod's up there. Grab my wrench off the other end. Let's roll this guy over. And each one of these rods is currently tightened just by hand with a speed wrench. Nothing crazy. So the next thing we're going to do is we're going to torque the rod bolts. So the torque on our rod bolts is 63 foot-pounds. And I've got a torque wrench set up ready to go. And with half the crank ready to go, we're going to torque now. Turn the crank. Man, this thing turns nice. Okay, so rod bolts are torqued. Next step, we need to see how much side clearance we've got on the rods. Now, rod side clearance, there's a minimum number, and that's more important, honestly, than the maximum number. There's 16. It's 18. That's 18. That's 18. That one's 18. And we may have a little bit more. So let's find out. Let's see if we can get a 20 in there. Nope. That one will take a 20. That one's a snug 20. And that one's a snug 20. Let's try this one again. It is a snug 20. So we're a snug 20 on our rod side clearance. That's genuinely good. Excellent, actually. 20 is a great number. Now at this point, we can wipe up some of this extra WD-40. And right now we have a short block. All right. So By the way, it smells real good in here. It smells like WD-40.
Okay, so that pretty much wraps up the short block assembly, and to finish it off, I put the lifters in, installed the dog bones and the spider, and that leaves me with a short block that's now ready to have cylinder heads put on and ready for windage tray, oil pump pickup, well, all of that stuff. So we're getting really close to having a complete long block here. Okay, really close, and that's actually kind of exciting because that means this car is potentially going to run in the next couple of months. Just got to get a bunch of other stuff done too. Anyways, I want to touch on one thing, and you saw me use WD-40 for the lubricant on the piston rings, the piston skirts, in the cylinder walls, and you saw that I wasn't bashful with it. I mean, I kind of hose it down with WD-40. WD-40 provides the lubrication properties that we need to prevent metal on metal wear during startup. That's the whole purpose of it. Okay. It also prevents any kind of rust or corrosion from any moisture in the air from causing us any grief in the cylinder between the time the engine's assembled and the time the engine started for the first time. Now, why I use WD-40 is about 25 years ago. One of the reps from Total Seal came out to one of the shops I was working at, and he was showing us a dry powder lubricant for piston rings, and we were all kind of like, wow, this stuff is trick. It's cool. And indeed, it was. And I believe they still sell it. The thing was, the reason they were using it was substantial. And that was what they had found is build the engine, run the engine. The compression didn't come up to where it needed to be very quickly. It didn't come up where it needed to be as quickly as it could. And so they studied it and they tested it. And what they found was when you take a piston and rod and you put the rings on it and you dunk that assembly in a can of oil and then compress the rings and put it in the cylinder, the oil goes into the cylinder and it fills in all the hone marks. And then the minute you start the engine, that oil turns to a hard carbonized glaze that basically makes the cylinder walls smooth. Okay? So you lose the valleys in your hone marks to that glaze. Well, that means you're robbing the piston rings of the necessary lubrication that they need to glide on. You're robbing them of their hydrodynamic sealing value. And as a result, this is why when a lot of engines were built back 30 plus years ago, you would see the engine builders say, yeah, drive it pretty easy for the first 500, 1,000, 2,500 miles even. And these were because of the recommendations were because of the glazing occurring in the hone marks in the cylinder. And if you filled in the hone marks with carbonized oil, you didn't have the sealing factor that you were looking for, right? It also didn't allow the piston ring to properly seat to the cylinder wall and to the hone marks. With this engine being plateau honed, we don't have to worry about the sharp peaks of the hone marks damaging the rings. And so there's not the same kind of break-in that we had in the past. What we're actually looking for is to have that oil produce that additional sealing factor on top of the ring, so that we have a good quality compression value, compression reading, cylinder seal, a very low leak down right away. And in the case of this engine, this thing will pass a leak down test probably after 20 minutes of runtime. And it'll be less than 5% leak down. and that'll be excellent. It should be cranking somewhere in the 200 psi range right at initial break-in, right after 20 minutes. And again, that's because of the way the engine's being built. The WD-40 gives us the advantage of not glazing. It will actually burn and leave clean hone marks. And by leaving the hone marks clean, it means that we will have proper lubrication on the rings, better ring seal, proper break in, and the break in will be almost immediate. This is much closer to the way an OEM engine is built these days, and this is kind of why on an OEM engine they can put synthetic in them almost immediately right at the factory. So this is just a change that I adopted way back 25-ish years ago, and I've used it ever since, and it works excellent. It does a fantastic job. The better the finish on the cylinder, the better the quality of the ring, the better the WD-40 works. Period. That's what I've found. And I'm sure that I'm sure that there's other lubricants that can be used besides WD-40. And if that powder form lubricant from Total Seal is still out there, I'm sure it still continues to work fantastic. So I'm not saying this is the only way. I'm not saying this is 100% the best way, but I'm saying this is so much better than dunking the piston in 30 weight or 10W30 or Rizlone or automatic transmission fluid or any other oil or lubricant that you might think to dunk your piston into. Just don't do it. WD-40 is a vastly better choice. And do some research, talk to ring manufacturers. If you really want to get fancy, go for it. I encourage that. But this works for me. I've had no issues using WD-40, and I'll continue to do it for a long time. Unless somebody can come along and say, hey, this is the same basic cost or nearly the same cost, and it has a benefit over what you're doing. At which point, I'm all ears. Okay? I'm all ears. So, again, thank you for watching. I appreciate all of you guys, and I hope this has not been too boring a video, like we broke some stuff, right? How often do you get to see somebody actually admit they made a mistake, right? But anyways, I thank you guys for watching, and I'll see you in the next one.